Oh. Hello everyone. I am Mark Zett. I am the owner of a small machine shop located here in Phoenix City, Alabama, called Powertrain LLC. I am the owner of a Rotorway helicopter, just like many of my audience probably is, or as many in the audience may aspire to be. And it was a lifelong dream to own one of these aircrafts. Since I was actually in the military, I was a UH-1 helicopter crew chief. I was on flight status. I have approximately maybe 600 hours as a crew chief in the Huey, but the crew chief always sat in the back seat, so I've always wanted to get in the front seat. So when I found the opportunity to get my own bird and finally be my own pilot or what have you, I took a jump on that opportunity, and I'm so glad that I did. And for those of you who would like to get into the amateur built rotorcraft, and you're in the Alabama area, there is one gentleman that I would highly recommend that you talk to. And this gentleman's name is Mark Peterson. He does not endorse any of the products on which I have developed. He does not endorse any of them, so I must be fair about that. So I'm not trying to deceive anyone. Well, Mark endorses this, since Mark is a very, very well-known person. I'm just merely saying that he was my CFI, and the confidence that he exhibited and the thoroughness of the knowledge and understanding of the aircraft that he presented, because like I said, he is a builder, he is a pilot. It was something about me that inspired me that, okay, the ultralight, well, I would say ultralight, the experimental category has to be safe. The level of confidence that he had was just all it took for me to win me over to get an experimental aircraft. I bought my aircraft secondhand from Mr. Mark Peterson, and well, actually he was pretty much a third-party seller. And what really got me was the fact that Mark knew all about what was in the logbooks to this aircraft. He knew it like the back of his hand, what was due, what was not due, and who did this. It seemed like it was almost like he had a personal relationship with the actual builder. And I know he went over this aircraft with a fine-tooth comb, because when I went to his home to look at this aircraft, he was ready to go flying. So that really inspired confidence in me that this man really knows what he is doing. And if you're I don't know whether he has aircraft for sale at the moment, but I would highly encourage you to give him a call. That's Mark Peterson, and the website is airmarkhelicopters.com. I just had to give homage to this man because he just inspired me to do what I've done thus far. Now, I guess the reason for this video is, well, like I say, I do own a small machine shop here in Alabama, and I have developed a couple of products that I feel that would really not only improve the liability of these aircraft, to inspire youth to pilot confidence, and I think it would actually add a little bit of more power. We all crave power. That's one thing about the Rotorway series. They all They're very, very nice aircraft, but a little more power is always to be desired. And I think some of the products that I had developed, they do just that, add a little bit more power while at the same time increasing reliability. Not only that, but some of the inspections that are in the Rotorway manual, some of these modifications to actually decrease the inspection intervals of these particular components, or altogether eliminate them. But first things first, let's talk about our flagship product, which I'm very, very proud of to introduce. And that, my friends, is no more than the hydraulic roller camshaft made specifically for the Rotorway engines. To my knowledge, it does fit the of course it fits the 133 series, because the engine that I actually have before me is a 133 series. And the camshaft, the original camshaft that I patterned out of it was from a 162, and those cams do fit from the 162 to the 133, so that we do know these cams are interchangeable between the 133 and the 162. I can't honestly vouch for the 145 and the 152 because I've never touched one. I don't own one. So I chose to do it on the 133 because I have two of the RW133 engines, and I only have one of the RW162 engines. And the 162 engine is actually installed in my aircraft, my airworthy aircraft. So I didn't want to break into that just yet until I saw how well these modifications were going to hold up on the test stand in the RW33. And besides, the RW33, Rotorway no longer supports it. So parts are very hard to find for this. Well, unless you go buy them used, of course, like through eBay, in which I bought both of these 133s. I bought them through eBay, and one of them had been dropped, or actually, I don't know whether it dropped or crashed, but one of the heads was destroyed on it when I got it. And the other one was, it was fairly good shape. There was a bit of backyard engineering done to some of the components on it, but all the parts were there, and I was actually able to fabricate some parts, and I now have everything together that I need to put this thing together. And so today I actually got the camshaft. I actually got it today, and I was very excited to get it because can't start actually assembling the engine without the camshaft, because, well, you can't get it in the case halves once you have the case halves bolted up. So I finally got it after about maybe 6 weeks of waiting, 6 or 8 weeks of waiting anyway. But anyway, now I'm going to speaking with the vendor, I'm going to start doing all of my cam blanks in-house. I do have lots of, well, actually I have, I can't say I have lots. I do have 2 CNC machines. I have a Haas milling machine, and I have a Haas lathe, all CNC. So hopefully when I'm doing the cam blanks in-house, it'll be able to cut down on some of the price to make it more affordable to the end user. By doing a lot of work in-house and only doing the final machining at the outside vendor. Okay. Now the camshaft. In the 162F manual on page 11, you are given the specs excuse me, for the camshaft that is used in the 162 engine. It has the valve lift, and then it has the lift, well, it has the cam lift, I'm sorry, and then it has the lift at the valve. And I kind of computed that out to be kind of like a 1.4 or a 1.5 ratio, whatever, I forgot the specific number. But anyway, the new cam, the hydraulic roller, even though these cams looks quite a bit different. This is hydraulic on my roller on my right hand side, well, left hand side, sorry, and this is the solid flat tappet on my right hand. I don't know whether you can actually get a good look at that or not, but you could take a look at the cam lobes and you can see how peaky this one is to a point and how rounded the roller is. Well, that round area that you see on the hydraulic roller, both of these cams have the same lip, exact same lip. All of this round area that you see here, all of that is area in which the valve is open as compared to it being closed with the pointy cam. And then all of this little area here is called area under the curve. And it just simply means that basically your valves are going to be open sooner and longer, and it's going to generate more power. The duration figures, which is also how long the valves are open, are the same for both of these camshafts also. So this is not, the hydraulic roller camshaft here is not a radical cam at all. The cams is the exact same specs as the flat tappet, except it's in a hydraulic roller configuration. And another reason why I wanted to try to fit these engines with the hydraulic roller camshaft, other than more power, is the reduction of friction. As we all know, friction is heat. If you look at the hydraulic lifters themselves, this is the roller design that has a roller here which gently rolls over this surface here. And just smooth as a button. And on the solid flat tappet, you have a flat surface here that just corresponds to this flat surface here, just such, which opens and closes the valves, which is a really high friction area. And believe it or not, well, even though you can't tell by the naked eye, this is really not a totally flat area on these lifters. There's actually a little bit of an angle on here and on the camshaft. And what this angle does, this angle actually helps this lifter to rotate in the bore. Because actually, if it wouldn't rotate, the lifter will actually wear out very, very quickly. So even though they look flat, they are not flat. And on the flat tappet cams and lifters, I'm not sure about on the Rotorways or not, but I do quite a few race car engines, and the more economical guys like to use the flat tappet cams because they're more economical. They're a lot cheaper. So, but one problem that we do have with the flat tappet, whether it be a hydraulic flat tappet or a solid flat tappet camshaft, is that since all of the zinc has pretty much been taken out of the oils that was mandated by the EPA, there have been lots of lifter failures that are associated with all the flat tappet designs. This is one reason why your manufacturers have moved, or the automobiles have moved to the hydraulic roller configurations. It was a warranty deal, plus the lack of the ZDP in the oil were causing these cams to fail. These lobes on these were just white flat, and the area in which made contact with these lobes, they would actually be dished. And once that happened, your cam and your lifter is toast. The only option you had at that point was to totally disassemble the engine, replace the camshaft, replace the lifters, and use a break-in oil with high ZDP to prevent that from happening. And even after the break-in of the camshaft, which is takes like 20 minutes to run it, I forgot the exact number, around 2,200, 2,500 RPMs or so to break in the camshaft. Even after the break-in and you're actually driving the car, every time you change the oil in the car, it was recommended that you put ZDP in these engines to prevent that premature lifter failure. But with the hydraulic roller configuration, I'm sorry, that lifter wear, that lifter failure was a thing of the past. So, and one reason why I warrant the hydraulic configuration in my Rotorway engines is because all of the engines, car engines that I build for myself, even if they came from the factory equipped with the hydraulic flat tappet camshaft, I never put a hydraulic flat tappet camshaft back in. Me, I'm just an anti-hydraulic or solid flat tappet camshaft type of guy. I don't want to bother with the worry about the premature failure, so it's hydraulic roller for me. And this engine here, this 133, it was the perfect opportunity for me to see could I adapt those same principles with the race engines to the 133, which is what I've done. Now, even though the camshafts here, they install, the hydraulic roller installs just the same as the OEM engine, there are a few high precision measurements or machining operations that you have to do to the crankcase halves in order to get the hydraulic lifters to fit within the bore. The first thing that you must do is that, I don't know whether you can notice or not, but the diameter of the hydraulic roller and the OEM lifter are different. There's a slightly bigger diameter of the hydraulic roller lifter. So that first operation included enlarging the bores to fit the hydraulic roller. The second thing that we had to do to both cases is, you see how this engine has a link bar on it? Had to make slight modifications on this too. There's a link bar here. Well, these hydraulic lifters, unlike the OEM units, these install after you have bolted the case halves together. And to gain access to put these puppies in here, tappets in here, we had to make an access port to get to the lifter bores themselves. And if you can see on this half, this elongated area here, all this has been cut out. Unlike the original OEM unit, it's a little heavy here. All you can see here are these 4 holes on each side, and what these holes did, they actually they held a push rod tubes. They held them directly. They had washers. Well, I would call them grommets rather. Poorly prepared here. That's unlike me. Hold on for a second. Hate being unorganized. Sorry about that. Professional. Anyway, this is your push-pull tube. This unit. All it does is just cover up the push rod that sticks into the lifter. As so. Goes in each one of the holes. There, 2, 3, 4. But once you go with the hydraulic roller configuration, you can no longer just use this to fit on the side of the block. And that is because I just showed you that area where those holes were has been machined away. So what we had to do to remedy that situation, once we had the lifters in place, we had to come up with an adapter. And this adapter, it'll sit in place just as such. And of course it will be, it will have gasket filler around it to keep seal any leaks and what have you. And then your push rod tube would stick in place like such. So that's because you no longer have those 4 holes in here. You now have this open space here. So that's the other major mod. And there's only one more mod, is actually where, since these are a hydraulic configuration, what we are going to, we want to make sure that there is enough oil flow to keep these lifters pumped up. And we felt the Rotorway design may not have been quite up to, well, they could have been better. These guys done a really good job, the Rotorway that is, on these engines, but we felt it could have been a little better, and I figured it's better to have, well, I figured you could never really have too much oil unless you're getting to the case of windage, which windage is bad because windage slows everything down, but there's not much really you can do about windage in this case. But this is a dry sump application. There's no crankcase that actually holds the oil, so windage is lessened along by that. But yes, but there are oil passages in here that we did re-drill. We actually interconnected some oil passages, so some of these lifters would get oil from, say, both sides, pressurized oils from both sides instead of just one. So we just wanted to make sure these lifters stay fed. So that is the only other modification we did, is cut out the holes for the hydraulic lifters that just drop down in there. Now, the second modification, well, actually, this is actually in process. I'm almost done with the prototypes. And these are some of the earlier prototypes in which I'm not finished, but I will have coming soon in the near future, very soon in the near future, hydraulic, not hydraulic, sorry, fully roller rocker arms for these engines. And yes, there will be needle bearings for the fulcrum here, and this is going to be another source of where we can actually reduce the friction on the engine. Like I said, those rocker balls on a standard rocker arm, they do get pretty hot, and that is a source, from on the articles that I've read, that is a source of a lot of heat. And well, for comparison, again, I know, poorly prepared now. This is the standard rocker arm, the OEM equipment from Rotorway. You can tell it has a groove portion in there in which this half a rocker ball fits inside. Well, the surface of this rocker ball here and the inside of this rocker arm here is a source of friction and heat. You have two surfaces rubbing together. Even though you have some an oil film in there, that is what I've read, a source of major heat into the engine. I forget what the degrees were where they tested an engine with this fulcrum here and a regular full rollerized valvetrain, but it was a few degrees difference. So my belief is every little bit of friction that's gone out of the engine helps, especially if it's going to produce more power. And there's no disadvantage to it, so why not do it? So this is in the works. I wanted to have it done. I actually wanted to have it done today, but when I checked, I was pretty much excited for my camshaft to come in today. So I guess I couldn't concentrate. And I was like, where are my cams coming? My cam's coming. So I said, well, hold off on the camshaft. I mean, on the camshaft, on the rocker arms. Once you're thinking straight and you're not all riled up because your cam is coming, you come back and you finish those rocker arms. So like I say, this is just a prototype because this shaft, it will be an alloy shaft here. This shaft is not an alloy shaft. This is a regular aluminum shaft, but the production shaft will be an alloy shaft. This is just for mock-up purposes because it is actually easier to machine aluminum for trial and error than it is to machine an alloy. For one, the bits are cheaper. You won't be breaking bits as much because alloy, this is a lot safer as far as bits are concerned for cutting. So camshaft, cases, the rocker arms, they will be coming very, very soon. And now moving on to the cylinder heads. These cylinder heads are, I say this is a 133. And one thing that we did do on the 133 to try and eliminate some of the inspections that the Rotorway manual actually calls out for, which is checking the lash cap, make sure that they're not actually sinking into the head here, the valve spring retainer. I guess over time, through wear, the valve spring retainers, the half circles, they can actually pull through these retainers and cause a drop valve or valve breakage or what have you, and that could be in flight. That's not good. So I'm the type of guy, well, if I see a problem and I figure that maybe I can correct it, I try to, or if I can make something better, I try to. It's in my power. I say, you know what, I can do that. I make that better, and that's what I will try to do. And this is one area I said, okay, Marcus, well, the factory Volkswagen, or actually Rotorway, well, the Rotorway design is directly from Volkswagen, and it is actually a dual groove system of keepers. But the valve has grooves in it, well, 2 grooves on the Volkswagen Rotorway design, and the high performance design only has 1 groove. The single groove design is stronger than the dual Volkswagen groove. And not only is it stronger, but the valve keepers that I'm using, they are 10-degree valve keepers. That meaning the angle is wider. So that means there's the chance of these valve keepers pulling through this retainer is greatly reduced. So I also figured that may be needed too, because with the hydraulic cams, they do, in all honesty, they do put just a little bit more tax onto the valve springs and retainers. So I figured that'd be a win-win situation if I were to go ahead, address that issue, get all brand new valves. So these are all brand new valves, all nice and shiny, nothing old. Basically, I just wanted to eliminate that possibility, because if the old design or the current OEM design was already having problems with the regular flat tapped camshaft, I knew we'd be having problems with a hydraulic roller camshaft. Even though it probably would have been cheaper per se per kit if I wouldn't even to address this problem and just go with the hydraulic roller, I couldn't in good conscience put something out there that I just wasn't sure of. Put it like this, if I won't fly it myself, I wouldn't push it out in the public. I don't know, I'm just funny like that, I guess. So, yeah, so I had the cylinder heads, we talked about the cam. Yes, one more thing. Now this, first of all, this is the OEM flywheel. This is the flywheel from a 133. As you can see, it only just has the ring gear, and this is like a quarter-inch. Was it quarter-inch or yes, I think it was quarter-inch aluminum. It's actually holding the flywheel, the ring gear, on. So the Rotorways, well, I'm not saying this would help or not, but these are nothing but Volkswagen engines, let's face it. And the Volkswagens, they came from the factory with flywheels that weighed up to like 30 pounds or so, I've read. So, and they actually ran smoother, and they could idle pretty low because that inertia from the flywheel, let's say in between the firing pulses, there was a dead spot there, but the inertia kept the crankshaft turning until the next pulse, which also helps decrease the vibration. The engine, God, not reaching for a harmonic. It's the word I'm looking for. The excitation from the engine. It helps reduce the excitation for those heavier VW flywheels. So what I had also designed, the last product, which I actually had this product on my 162F right now, and this is the flywheel that I designed. It is called the Inertiator. Currently, this one here is like 14 pounds, but I know what you're gonna say. Oh my God, you're trying to make our ships heavier. Yes, I'm trying to make your ship heavier, but I could honestly say when I installed this on my ship, as soon as the engine fired up, there was a noticeable difference from me just sitting in the cockpit. I'm like, wow. The engine, it was a lot quieter. It seemed like all those rattles that the engine that are normally there at the airframe, that engine and valvetrain, God, it's hard to explain. Those noises, those little vibrations, they were just gone. And I go out and I look at the main drive belts, and they used to flap pretty wildly. And I notice now, I'm like, wait a minute, they're a lot smoother now. The engine doesn't seem to be doing as much jerking as it used to. It doesn't shake as much as it used to. So, for those of you who are saying, well, you want to add another, I think it's 12 pounds. 12 pounds to my engine. Well, look at it like this. If you were, depending on when you bought your ship, if you bought it, whenever you bought it, put it like this. If you had the chain drive system in it, and now you have the tooth belt drive, the sprocket, like the Gates belt or what have you, that chain setup was around 12, 14 or so pounds heavier than the belted main rotor drive system. So even though you're pretty much back where you started from as far as weight wise on your ship, this made a tremendous difference as far as the way this thing idled. Even at flight idle, when I pick up the aircraft from pick it up to a hover, I notice I don't have to give it as much throttle. I don't have to manipulate the throttle as much as I used to without the when it had the original gear on it. And I was really surprised. It was just it was like a new aircraft. This is no joke, and it's just hard to explain. It was just that big of a difference. It was just not it was quiet, and it didn't seem to change the RPMs as much as it would with the original RPM. It seemed to, once you put it at a certain RPM, it tended to stay there. It took very little input to keep it at the RPM that you set it at. And I attribute that to the extra weight in the engine, as far as like wanting to keep the engine turning. Those in between those engine excitation pulses, I look at that inertia, that little inertia there, as help keep things turning, stop jerking everything around per se. And this is just my theory now. I'm not saying this is truth or what have you. But yes, the Rotorways used to have secondary failure problems. I'm not sure, so I'm not going to say this is gospel, but the changes that I really noticed as far as the smoothness of the engine when I did put on my flywheel, even though I have no proof to back it up, I would say that considering that the engine wasn't as jerky as it was and it seemed to fly a lot smoother now, I would say there's a lot less jerky motions going on in that secondary shaft, which I would say that the actions pulling on it now is more constant as far as like the jerking motion all the time. And just my opinion, but I just think that this is a lot easier on all the valvetrain, because I was really amazed when I put it on how smooth things became, how quiet things became. It was just phenomenal. And some of you may say, well, oh, that is this flywheel is a lot thicker than the original. This is so true. But as you notice, there is a pocket here. This pocket. This pocket right here is the same thickness as this. So this is not, it's not any thicker, and the ring gear rides in the same position as with this. It rides on this portion down here where this plate is. There's no, well, no, you're relocating where my ring gear is. No, that's nonsense. Your ring gear is in the same place with this as it is with this unit here. But one problem that I have noticed, Rotorway seems to have many different flywheels for would have used many different starter and ring gear combination over the years, and it was brought to my attention that I would have to produce several different flywheels depending on the application. So as So I figured that would be no problem. It's just a matter of programming the computer to do what it does. And the machine is pretty much just spits out what I reprogram it to do. It's just a simple manipulation of the G code. But however, these will not work if you have the ACIS system. The reason for that is the ACIS system has an extra belt on it. And once again, I'm not prepared. Please forgive me. Uh-oh. Ooh. Where are now? Uh-oh. Ah. Here we go. Okay. I am so sorry. Right. Okay, on your ACIS, this is the main drive pulley. Well, this one is actually from the 133, but anyway, you can see what I'm saying here. I guess on the engine that are equipped with the ACIS system, the supercharger, these walls on here, right here, this thickness here, this walls, there's the belt that actually feeds the supercharger is very, very close to the bottom of this surface here. And if you were to try to use these flywheels on the engine equipped with the ACIS, the supercharger, it won't work. Your supercharger belt would be dragging along the walls of the inertiator flywheel. So it will not work with engine equipped with the ACIS, but we have to work that on a case-by-case basis. Because at the moment I want to get this engine together, I'm going to be testing it, do some rigorous testing on it, and I want to put it through the paces, and I want to see just what it will do, see how long it holds, how well it holds up. So I'm pretty excited about that. I'm probably going to get this now, like 2 o'clock in the morning, whatever. So probably tomorrow I'm going to get a fresh start on starting to put this engine together. I already have some little things done. I guess I fitted the piston rings. I've already foul fitted the rings to the bore and all. To kind of speed things up once I did get the camshaft. And this particular camshaft I am going to degree it in, because I did use a degreeable socket, and I actually had to modify, well, not this wheel, but the bottom wheel that goes on the crankshaft for use with the Rotorway engines. Even though, well, the gear from the Volkswagen will physically fit on the Rotorway crankshaft, Rotorway does not utilize the keyway that is present on the Volkswagen gears. They actually machine a second keyway on those gears. So what was my point? Anyway, what I'm saying is basically I'm going to get started on this tomorrow. I'm going to keep you guys posted on I guess on YouTube with this. So I'm probably going to have the first startup actually on tape. Probably won't broadcast it live, but I'm going to get some more pictures of me putting this thing together, maybe some speed up the motion on it so you can see everything going together, how it goes together. Maybe the cam degreeing process, because I do have the green washers for this, because the factory says they want this particular camshaft installed 4 degrees retarded. Well, actually it's 4 plus or minus 1 degree retarded. And for those of you that don't know, when you're talking about advancing a camshaft and retarding a camshaft, okay, let's start with advancing a camshaft first. When you advance a camshaft, God, might be mixed up here, God, okay. I think you're actually having the valves open up sooner and closing later. And this is actually gives an engine more bottom end torque. So on the drag strip, we would, depending on how strong our engine was on the top end, it will, especially using an automatic as compared to a manual shift car, we would tend to advance the camshaft because regardless, an automatic has always taken bottom end torque from your car. So we would actually advance the camshafts to give us that bottom end power for a good launch. And when you retard a camshaft, we pretty much retarded the camshafts on our manual shift cars because the what retarding does, it moves the RPM band up in the range. Instead of, it kind of like sacrifices some bottom end power. Your bottom end becomes soggy, but this is a helicopter, so it doesn't matter how soggy your bottom end because you're operating at 4,250 RPM, so you can kind of like forget about the bottom end. There's no bottom end. It is of no concern. So this is why I see the factory has it retarded 4 plus or minus 1 degree. So we're gonna we're gonna try to stay with the factory specs. We're gonna retard it because we want everything pretty much as the factory would have it. So kind of excited. Maybe tomorrow I'll put in some, well actually later on today, like I say, it's after 2 o'clock at night. So a little longer today, later today, have another cup or 2 of coffee. I'm actually going to start putting this engine together. And I just want to see just what this thing can do. I haven't been able to find a dynamometer that does an engine in the upright position. So if any of you guys out there can find someone that actually has an upright dyno, maybe you can shoot me a comment in the comment box, and maybe I could, depending on the location, I could have this engine shipped somewhere where I could actually take it there myself and actually put it on a dyno to see exactly what it does. Because I do remember on one Rotorway site, it was a gentleman, he was a Rotorway guy, and he did have a dyno. And I can't figure out the life of me who this guy was now, so maybe that guy will watch this video of this and shoot me a line. Well, yes, and I also welcome your comments. I'm a pretty thick-skinned guy. I don't let anything bother me. So whether you have something positive to say, I want to hear it. If you have something negative to say, I still want to hear it. Because I see it like this here. Good comment or bad comment, you may have an angle that I never thought about, even though it's not a very nice comment. It may give me something to think about and actually figure out how to do something a better way or what have you. Because like I say, I don't know it all. I never claim to know it all, but I do welcome all your comments, good, bad, ugly. I take it as it comes. But I think that's it for now. Like I say, I'm Marcus F. from UG Powertrain. I'm located right here in Phoenix City, Alabama. So So I hope to have something for you guys pretty soon, and I guess please leave your comments in the comment section. Thank you.